Until these stations came into my hands, I thought they were identical, but as it turned out, they differ both internally and in terms of software. Today, I'll be reviewing the Fossibot F1800 and comparing it to the Aferiy P180. They have the same specifications and the same price, €449, cheaper with a promo code. Shipping across Europe is usually free. For this particular station, Fossibot collaborated with the Chinese company Sanyonda, SYD. Aferiy continues to work with them, while Fossibot decided they originally ordered this model from another manufacturer, so these stations are distinct from each other. The primary disadvantage of Fossibot is that it is noisier. Under a load of 1.6 kilowatts, the noise reaches about 60 decibels. Aferiy, under the same load, produces a noise level of only 45 dB. So if you need absolute silence, I would recommend looking at Aferiy. At low loads, the Aferiy's fans are completely silent, but the Fossibot at low loads periodically turns its fans on. The Fossibot is a bit longer, shorter, and both stations have a nominal power of 1,800 watts and a peak power of 3,600 watts. The battery capacity is the same, 1,024 watt-hours, and the weight of these stations is also approximately the same. To operate this station now, you need a different app, Fossibot Plus. All previous Fossibot stations will not work with this app. The first advantage is that this app works faster. Second, the station now has an eco mode. Now there are two charging modes, UPS or Eco. If the station is connected to the grid and a device is connected to the station, a solar panel, then when eco mode is enabled, the station switches to being powered by the solar panel and the station's battery starts charging exclusively from it. If the sun goes away and the battery discharges to 10%, then the station will automatically switch to being powered by the AC grid, but at the same time, it will not charge the battery. That is, ECO mode gives priority to using solar energy. Now, in the app, you can enable output memory. If the battery discharges and the station turns off, it remembers the state of the outputs, and then, when power is restored, it will turn on the same outputs again. There is also now the ability to set up 3 time intervals. You can set an interval just for charging or discharging, or for both charging and discharging. The charging power from the grid in the app can be adjusted from 100 watts to 1,200 watts. I recommend keeping the upper charging limit at 100%, and I recommend setting the lower discharging limit to 5 to 10%. When discharging down to 10%, the station emits an audible signal. If you use the DC input to charge the station by default, there will be an 8 ampere limit. This current can be adjusted from 1 ampere to 8 amperes, but you can also enable the expansion mode. And in expansion mode, you will get a maximum charging current through this input of up to 15 amperes. However, car cigarette lighters are not designed for such current and usually burn out. So there is a warning: do not use it in a car to avoid damaging the cigarette lighter. When expansion mode is enabled, the current can be adjusted from 1A to 15A. There is also an option to adjust the screen brightness. This is another small plus. You can set the screen off time. The standby time and the time for turning off the AC outputs without load have also changed. In addition to the typical options of never turn off, 8, 12 or 24 hours, there are now options for 30 minutes, 1 hour or 4 hours. The same standby time can be set for the DC outputs. And for the USB outputs, the Fossibot comes with a bag containing charging cables. There is a cable for charging from solar panels, from the AC mains, and from a car cigarette lighter. On the front panel, there are control buttons, a flashlight, and a DC output. And in this station, there is only one DC output, a 12-volt 10-amp car outlet. The voltage on it is 13.8 volts. This station does not have DC 5.5 by 2.1 outputs. The USB-A output has a maximum power of 18 watts. The Type-C output has a maximum power of 140 watts. And I mistakenly thought that the ports were independent. But as it turned out, you can only get 140 watts if you charge from a single Type-C port. There is a charging power switch for 400, 800 and 1,200 watts. And you can also use this switch to enable eco mode. These are portable power stations for camping, so they have flashlights. The flashlight on the Fossibot is brighter. The fans hidden under the handles, it uses 4 fans. just like you would find on the Aferiy. On the back panel of the Fossibot, there is no circuit breaker button for overload protection. Inverter power button. The buttons on these stations are not backlit. The maximum charging power for the Aferiy is 1000 watts, while for the Fossibot from the mains it is 1200 watts. On the DC input, the upper voltage limit is 60 volts, while on the Aferiy it is 55 volts. That is, to recharge the Fossibot, you can now safely use batteries with the nominal voltage of 51.2 volts. In fact, the power consumption of both stations with the 230 volts output turned on is about 14 watts. I connected the laboratory power supply to the solar panel input, set it to 13 volts, and without enabling the extended mode, the station draws about 100 watts. I remind you that for voltages up to 14 volts, most similar, these stations have a standard charging limit, not more than 8 amperes, but if you enable the extended mode, then the station will draw a total of 190 watts. If you use a 24-volt battery and enable it again, the extended mode, you can get 400 watts at the solar panel input. If you use an LFP battery with a nominal voltage of 51.2 volts, the station will draw about 500 watts. This is how the eco mode works. There are two icons on the screen. One icon shows the city grid at 230 volts. The other shows the voltage at the solar panel input. With eco mode, even with grid power, battery charging power comes from solar panels. USB testers on both Type-C outputs showed PD 3.1 at 140 watts. Quick charge is included too. Charging protocols developed by Huawei, Samsung, and MediaTek Pump Express. And it also supports the Chinese UFCS at 105 watts. If you connect one device, the station delivers 140 watts. I tried connecting an additional power bank that is capable of charging at 140 watts, and the station outputs a total of 17 watts and no more. I use good Type-C cables rated for 240 watts. So you can only get 140 watts when using a single port. The app also displays the power output on the USB ports. On the Aferiy, only one output supports power delivery, at 140 West. The second one is 20 West. And when two devices are connected, the Aferiy delivers 140 watts on one port and up to 18 watts on the other. Now it's time to put a load on it, the station, and see how it performs. I connected a 1.6 kilowatt oil heater. The noise is about 65 dB. A 2.2 kilo hair dryer from a 230 VF outlet draws about 1900 W. Here the station delivered 1890 watts at the station's output. The voltage did not drop, it remained around 230 volts. A 2 kilowatt kettle, when the voltage is 230 volts, draws 1930 watts from the grid. And when the kettle was turned on, the station delivered 1940 watts for a few seconds, and then the power dropped to 1800 watts. As it turned out, this station, just like the Aferiy, is able to reduce the output voltage in order to power a more powerful consumer. With a 1 kilowatt electric stove, I decided to try another pot with a thin bottom. And in order to boil a liter of water, it took about 20% of the energy. And the stove kept turning on and off. So if you want to cook food on such a station, it's better to use a more powerful stove. Choose one with 1.5 kilowatts or 2 kilowatts. A 500 watt kettle boiled 300 milliliters of water using 4% of the energy. For fully discharging the station, I used the Type-C port, and the station delivered 940 watt-hours. Aferiy, under the same test, delivered 915 watt-hours. When discharging through the outputs, when discharging through the AC outputs using an oil heater, the station delivered 990 watt-hours. In this test, Aferiy delivered 915 watt-hours. And the fact that the Fossibot delivered 990 watt-hours really surprised me. The battery capacity is 1024 watt-hours. So, either this station uses high-quality batteries, or the BMS isn't configured to shut off to prevent over-discharge, although new batteries usually deliver more energy. Regarding the charging algorithms, The Fossibot F1800 is stricter in this regard. At 1200 watts, the station charges the battery at 1200 watts almost until the end, and in about 1 hour and 10 minutes the station is fully charged. At a charging power of 800 watts, the station charges in 1 hour and 30 minutes, and the power also does not decrease almost until the very end of charging. The same story applies to the 400-watt charging power. At the station's output, we get a perfect sine wave even under the load of a 2-kilowatt kettle. In all modern stations with a built-in power supply unit, there is a UPS mode. This station also has this mode, and it works quite quickly, up to 10 milliseconds. I took a few shots. The switching happens quite fast. The computer also doesn't notice such switching. And now comes the most interesting and the most complicated process is disassembling the station. The top cover is screwed on with studs. If you unscrew them, the cover comes off easily by the handles. Two 60mm fans on one side and the other side. The fans are 12 volts at 0.17 amperes, and they are controlled by a PWM signal. The side panels are also on rather simple latches and can be easily pulled up. On all boards there will be markings ABUF 1800, chokes on ferrite cores, and the first letters KD. KD usually stands for the station manufacturer, but which manufacturer exactly, unfortunately, I do not know. If you have seen these markings on other stations, please write which stations you saw them on. Here is the general appearance of the inverter and the MPPT controller. Litz wire is the multi-stranded copper wire used in chokes with increased quality factor. At the grid input of the station, there is a fuse, common mode chokes, X capacitors, varistors, and an input relay labeled Zettler. Zettler is a German company, but these particular relays are manufactured in China. They are labeled 20A277V and 17A277V. The electrolytic capacitors used are KNS-CHA. I don't know what kind of capacitors these are. If you've come across them and know about their quality, please write about it in the comments. The transistors in the high voltage section, 4 transistors rated for 40 amperes and 2 transistors rated for 60 amperes. These are from the Chinese company Lonton. I haven't come across these transistors before. They are rated for 650 volts and 40 amperes. But these ones I have seen more than once. These are transistors rated for 650 volts and 60 amperes. On the heatsink, on the low voltage side, there are 4 transistors installed on each side. And these are also transistors from Lonton, rated for 100 volts and 120 amperes. This is what the inverter board looks like from below. Here is where the microcontroller is located, along with several drivers. The drivers are SLM8253BD, and the microcontroller here is from Texas Instruments model F28039. The battery pack is assembled from 16 lithium iron phosphate cells connected in series. The battery capacity is 20 ampere hours. The size is 40 by 135, but all the markings are in Chinese. Google Translate led me to the Chinese company DFD New Energy. In the specifications of the battery, it is stated that it can be both charged and discharged at a 2C current. BMS, the BMS has 5-watt resistors for the pre-charge system, and as you can see, here transistors in toll packages are also used. Quite soon, in almost all portable power stations and BMS, you will see transistors specifically in toll packages. Here as well, a dozen transistors from Lonton are used. They can withstand voltages up to 100 volts and currents up to 300 amperes. The balancer is passive. There are 16 resistors of 100 ohms each, so the balancing current is about 35 milliamperes. And the balancing and protection of the battery is handled by the Sine Wealth SH367309U controller. This is a popular controller for LFP batteries. Communication between the boards takes place internally via RS485. The front panel board has several transistors. The SW3566H is used as the controller for the Type-C connectors. It supports power delivery 3.1 UFCS 20 volts 7 amps and 28 volts 5 amps. It is stated that it supports dual-port independent operation, meaning independent dual-port functionality. However, it cannot deliver 140 watts to both ports simultaneously. That is, the maximum it can output is only 140 watts. And on the board of the front panel, there are also several of these voltage regulators. And as for the Wi-Fi Bluetooth adapter, an ESP8684 is being used. I will now wrap up the video here. In conclusion, it's quite good. There are useful features. An eco mode, it can handle more load than stated. It delivers an impressive 990 watt hours. As for integration into a smart home with the standard, you won't be able to use Fossibot integration because it only works with products from SYD. Although the Aferiy P180 also, for now, does not work with this integration. These stations are too new. And with that, for now, I'll be ending the video.